Artificial intelligence. For some, it's the inception of a utopian future. For others, a ticking time bomb set to spell humanity's doom. The truth, however, lies somewhere in between, and often far from what Hollywood and viral internet posts would have you believe. AI seems to be at the center of endless debates and wild claims, from fears of self-aware robots ruling the world to promises of machines replacing every human job. But how much of this is grounded in reality, and how much is just a modern-day myth? In today's video, we're peeling back the layers of misinformation to reveal the truth about one of the most talked about technologies of our era. There's a lot of noise about AI, isn't there? From dystopian prophecies of killer robots to utopian fantasies where machines fix everything, we're constantly bombarded by extreme viewpoints. But here's the thing. Neither of these polar extremes presents the full picture. Artificial intelligence is undoubtedly powerful, but it's nowhere near as omnipotent, nor as apocalyptic, as we're often led to believe. The myths around AI aren't just harmless misconceptions. They shape how we develop, regulate, and even fear this rapidly evolving technology. This makes separating fact from fiction not just important, but essential for anyone living in our increasingly AI-infused world. So, why do these myths stick around, and how can we approach them with clarity? That's exactly what this video aims to answer. From the idea that AI is thinking like humans to the fear of machines overtaking humanity, we'll break down the 10 most persistent AI myths and reveal the reality behind each one. Prepare for a journey that will challenge not only what you've heard, but possibly what you've assumed about the role of intelligence itself, human and artificial alike. Let's dive in. It's a common misconception. Because AI systems like ChatGPT can compose essays or play chess at a grandmaster level, they must be smarter than humans, or even capable of independent thought. But here's the truth. AI isn't smart in the human sense at all. Unlike people, AI has no consciousness, intuition, or understanding. What AI does exceptionally well is process vast amounts of data to recognize patterns and perform narrowly defined tasks. For example, AlphaZero dominates chess and Go not because it understands these games, but because it was trained to evaluate millions of possible moves rapidly and identify optimized strategies. Similarly, language models like ChatGPT generate text based purely on statistical patterns learned from large datasets, not because they know what they're writing. This lack of genuine comprehension is one of AI's most significant limitations, albeit cleverly masked by its outputs. AI's brilliance is confined to narrow domains where it's explicitly trained. It can write poetry based on patterns in existing works, but doesn't feel emotions or consider deeper meanings. It might diagnose diseases with impressive accuracy using medical images, yet it lacks the judgment or empathy of a human doctor. For any task outside its programmed scope, AI flounders. Think of AI as an incredibly skilled worker with tunnel vision, perfect at repetitive or data-heavy jobs, but incapable of problem-solving or thinking beyond its instruction set. This isn't intelligence as we know it. It's more like automation on steroids. Understanding AI's strengths and limits is crucial to appreciating what it can and can't do, and how it complements, rather than replaces, human capabilities. When many people think of artificial intelligence, their minds flash to scenes of rebellious robots or rogue systems from Hollywood blockbusters. The Terminator, The Matrix, or I, Robot come to mind, fueling fears of AI overlords bent on humanity's destruction. But here's the key difference. These stories spring from the realms of fiction, crafted to entertain and provoke, not to reflect AI's true capabilities or intentions. AI, as it exists today, doesn't possess independent desires, self-awareness, or the ability to override human control. It's software, not sentience. Current AI systems are meticulously trained to perform narrow tasks, whether that's recommending movies or identifying objects in photos. They're impressive, but fundamentally utilitarian, lacking the intent or autonomy necessary to pose any inherent threat to humanity. Now, what about the possibility of misuse? It's true that any tool, not just AI, can be exploited for harm if it falls into the wrong hands. This is why safeguarding AI development has become a global priority. Governments, Tech companies and ethics researchers are establishing frameworks to prevent misuse. For example, OpenAI, one of the leading AI organizations, emphasizes safety research and transparent development. Meanwhile, international policymakers are working on regulations to ensure accountability in how AI is used, requiring stringent oversight in areas like military applications, facial recognition, or autonomous systems. These measures act as a crucial buffer, drastically reducing the likelihood of any AI application being misused to catastrophic ends. Finally, let's address one critical point often overlooked: the human element. AI doesn't make its own decisions, it executes instructions provided by us. The idea of AI taking over humanity assumes it could outthink and outmaneuver us autonomously, but no current system operates at that level. Ethical AI design explicitly prevents the creation of systems with unchecked authority. Rather, the responsibility for how AI is used lies squarely with its developers and operators. So instead of fearing invisible AI conspiracies, the focus should be on responsible innovation, building systems that work alongside humanity to solve problems, not create them. Let's start by examining the idea that AI can make decisions entirely on its own, a claim that often sparks both fascination and fear. While artificial intelligence systems give the appearance of independent decision-making, this is an illusion. Behind every AI system is a foundation of human-provided algorithms, rules, and training data. When an AI model produces an output, whether it's recommending a movie, diagnosing a medical condition, or identifying objects in an image, it's following mathematical patterns and instructions pre-programmed by people. In other words, AI is not choosing anything the way a human would. It's executing processes designed by human engineers to optimize results for specific tasks. Another key point to understand is that AI lacks consciousness or awareness, attributes necessary for truly independent decisions. Unlike humans, who make choices informed by emotions, intentions, and contextual understanding, AI operates within narrow boundaries defined by its training data. For example, a chatbot that seems to carry out a conversation does not understand the words being exchanged. It's simply predicting the next most likely response based on patterns in its data set. Strip away that training, and the system is effectively useless. This is because AI, no matter how sophisticated, cannot independently conceptualize or reason without explicit directions encoded within it. To ground this concept, consider a self-driving car as an example. It might seem like the vehicle is autonomously navigating the road, but it's actually following a complex series of programmed instructions. These cars rely on millions of human-labeled images to recognize traffic signs, identify obstacles, and perform actions like stopping or turning. If the data it was trained on excludes a rare edge case, say, encountering a unique type of road hazard, it won't know how to handle it. This highlights how AI systems depend entirely on their training environment. They don't decide to adapt. They only function within the parameters set for them by developers. When discussing artificial intelligence and employment, the fear that AI will eradicate all human jobs is one of the most pervasive myths. However, history tells a different story. Technological revolutions, like the Industrial Revolution and the rise of the Internet, have repeatedly transformed the workplace, not by eliminating jobs entirely, but by changing the types of roles available. AI follows the same pattern. While it's true that AI can automate repetitive and routine tasks, it also opens doors to entirely new industries, stimulates demand in adjacent sectors, and allows humans to focus on more complex, creative, or interpersonal work. For example, AI-powered tools can handle data analysis at a scale humans cannot manage alone. This, in turn, supports roles like data strategists and machine learning engineers, professions that didn't even exist a decade ago. The relationship between AI and the workforce isn't one of simple replacement, it's one of augmentation. Think of AI not as a competitor, but as a collaborator. In healthcare, for instance, AI applications like diagnostics and predictive analytics drastically reduce the burden on doctors by quickly analyzing patient data, but professionals still make the final decisions based on this input. The same principle applies in education, marketing, and even art, where AI serves as a tool to amplify human potential. The key takeaway here? Instead of fearing job loss, we should focus on evolving skill sets to work alongside AI. Organizations, governments, and educators have a responsibility to prepare current and future workers for an AI-driven world, ensuring that the benefits of these innovations are widely and equitably distributed. Myth 5. AI understands emotions. Let's begin by addressing a widespread belief that artificial intelligence has the ability to truly feel or understand human emotions. This misconception often arises from interactions with seemingly empathetic chatbots or advanced sentiment analysis tools. But here's the truth. AI doesn't actually feel or comprehend anything. It processes inputs and generates outputs based on patterns and data. While the technology might convincingly simulate an emotional response, it's important to remember that this simulation is purely mathematical. It's a product of programming, not genuine understanding or subjective experience. Take sentiment analysis, for example. This is a commonly used AI feature that evaluates large sets of text data, like customer reviews or social media posts, and classifies them as positive, neutral, or negative. On the surface, this seems impressive because it mimics a basic form of emotional awareness. But in practice, sentiment analysis often struggles with nuance. It can misinterpret sarcasm, fail to identify context, or oversimplify complex emotions. For instance, a sentence like, "I love the product, but the shipping was a disaster," might confuse an AI system, which could misclassify it as wholly positive or negative depending on how it has been trained. This reveals the limits of AI's emotional understanding. It can only work within predefined patterns, failing to truly grasp human complexity. Chatbots provide another prime example. Many of us have interacted with AI-driven assistants like customer service bots. These systems are getting better at responding in natural, conversational ways, sometimes even using supportive language like, "I'm sorry you're feeling this way." But this doesn't reflect actual empathy. Instead, it's a pre-programmed response designed to fit specific scenarios. The chatbot isn't feeling sorry. It's using algorithms to match your input with words that seem appropriate. This invites the question, can we mistake convincing simulations for real emotional connection? The answer underscores an essential limitation of AI. No amount of code or data makes these systems sentient or emotionally aware, and myths about emotional AI risk fostering unrealistic expectations about their capabilities. Let's start by confronting a common belief. AI is objective and entirely unbiased. While tempting to think that machines operate free from human prejudices, the reality is far from simple. AI systems are trained on data provided by humans, and humans, whether intentionally or inadvertently, bring their own biases into the datasets they create. For example, consider language models trained on text scraped from the internet. If those texts reflect underlying societal prejudices, such as stereotypes based on gender, race, or socioeconomic status, AI systems will absorb these patterns and replicate them in their outputs. When unchecked, an algorithm doesn't just inherit these biases, it sometimes amplifies them, perpetuating inequalities in areas like hiring systems, lending practices, and even criminal justice. To illustrate this, let's explore some striking real-world examples. In 2018, a recruitment algorithm developed by a major tech company was discovered to discriminate against female candidates. The system, trained predominantly on resumes submitted by men over the years, associated male-centric language and career patterns with greater hiring success, unintentionally filtering out female applicants. Another noteworthy incident occurred with facial recognition software, which became infamous for its inability to accurately identify individuals with darker skin tones. These biases don't solely stem from malicious programming. They arise due to gaps in representation within training datasets, where images of lighter-skinned individuals might disproportionately dominate. So what's the takeaway? Bias in AI doesn't originate from the technology itself, but rather from the data and programming choices made by humans. This means that addressing AI bias requires intentional design and proactive efforts to ensure fairness. Researchers are now investing in methods like diverse training datasets, bias detection algorithms, and regular system audits to better mitigate these issues. While AI has incredible potential to empower, it must be developed responsibly to avoid reinforcing harmful stereotypes. This myth, The idea that AI is somehow above human flaws is an important reminder of why ethical consideration and transparency are vital in shaping its future. Let's start by clearing up a common misunderstanding. Artificial intelligence and machine learning are not interchangeable terms, nor do they mean the exact same thing. Artificial intelligence is a broader concept. Think of it as the overarching field dedicated to creating systems capable of performing tasks that typically require human intelligence. This includes problem solving, pattern recognition, reasoning, and even language understanding. Machine learning is a subset of AI. It refers specifically to the methods and algorithms enabling machines to learn from data and improve their performance over time without explicit programming. To put it simply, all machine learning falls under AI, but not all AI relies on machine learning. To illustrate this distinction further, let's examine machine learning in action. Imagine you're watching a streaming platform that recommends movies based on your viewing habits. The recommendation algorithm learns from your data to suggest titles you'd likely enjoy, and that's machine learning at work. However, if that same platform uses another AI system to automatically generate subtitles or analyze scenes for copyright enforcement, these systems may not rely directly on machine learning. They could employ rule-based AI or other techniques like image recognition. This demonstrates how machine learning is just one tool within AI's massive toolbox, not the entirety of artificial intelligence. In fact, the broader AI landscape includes other technologies, each serving specific purposes. For instance, natural language processing, NLP, focuses on understanding and generating human language, enabling voice assistants and chatbots. Computer vision deals with interpreting images and videos and powers applications like facial recognition and autonomous vehicles. None of these technologies are strictly machine learning, but they often integrate ML techniques to enhance their capabilities. As AI continues to evolve, understanding these distinctions helps us appreciate how diverse and interconnected this field truly is. To debunk the myth that AI is a recent invention, we need to go back to the mid-20th century. The seeds of artificial intelligence were planted in 1950 when British mathematician Alan Turing proposed the famous Turing test in his landmark paper, questioning whether machines could exhibit behavior indistinguishable from human intelligence. This concept became a cornerstone for future AI research. Shortly after, in 1956, the term artificial intelligence was formally introduced at the historic Dartmouth Conference, where early pioneers like John McCarthy, Marvin Minsky, and Claude Shannon outlined what they believed machines could achieve. Far from being a sudden phenomenon, AI has its origins in decades of academic exploration and technological innovation. AI's journey through the decades was marked by cycles of optimism and stagnation, often referred to as AI winters. During these periods, funding dried up due to unmet expectations. Notable breakthroughs, however, kept the field alive, such as the development of ELIZA in the 1960s, an early natural language processor designed to mimic conversation. Similarly, Frank Rosenblatt's work on perceptrons in 1958 laid the foundation for modern neural networks. While these systems were rudimentary by today's standards, they illustrate how AI was evolving long before it became a buzzword in pop culture. Fast forward to the 21st century, and the rapid growth of computational power and the availability of data have driven the AI revolution we see today. But even the technologies we now marvel at, like machine learning models and generative AI, are direct descendants of decades-old concepts. In essence, AI isn't something that burst into existence overnight. It's the culmination of incremental progress, trial and error, and interdisciplinary collaboration over nearly 70 years. Recognizing this history helps dispel the myth that AI is a new phenomenon and grounds it in the reality of its long and painstaking development. First and foremost, it's crucial to dispel the notion that AI is incapable of making mistakes. Artificial intelligence is, at its core, a tool crafted by humans and powered by data, and both factors introduce imperfections. For instance, consider facial recognition AI systems, which have been shown to misidentify individuals, especially women and people of color, due to biased training data. A 2018 study discovered that certain facial recognition algorithms had error rates of up to 34% for dark-skinned female faces, compared to less than 1% for lighter-skinned male faces. This stark discrepancy highlights how flawed datasets can lead AI systems astray, sometimes with serious consequences like wrongful arrests or misallocation of resources. In addition to biases, AI systems are limited by the scope of their training. Many AI models rely on historical data, which can lead to failures when encountering unforeseen scenarios or rapid shifts in societal norms. This issue became evident with an AI chatbot launched by a major tech company in 2016 that quickly spiraled into controversy. The system began generating offensive language after interacting with online users who fed it harmful input. This episode underscored how AI's lack of contextual understanding and susceptibility to manipulation can result in unexpected and undesirable behavior, especially when human oversight is absent. Finally, AI systems are not immune to security vulnerabilities. Some models can be exploited through adversarial attacks, essentially tweaking inputs in subtle, calculated ways to deceive an AI into making incorrect predictions. For example, image recognition systems can be tricked into misidentifying objects if attackers introduce slight alterations that remain invisible to humans, like adding imperceptible pixel noise to an image of a stop sign, making the AI perceive it as a speed limit sign instead. Such vulnerabilities highlight the need for constant vigilance, ethical programming, and robust security measures to mitigate risks associated with AI deployment. Myth 10 argues that AI is replacing creativity, but this oversimplifies the relationship between artificial intelligence and human ingenuity. Creativity embodies originality, emotional expression, and the ability to synthesize ideas, qualities rooted in human experience. AI, on the other hand, excels at pattern recognition and generating outputs based on existing datasets. Consider tools like DALL-E or Midjourney, which can create stunning visual art based on user prompts. While these outputs may look creative, they lack personal intention or emotional depth. They're constructed from algorithms trained on human-created content. This illustrates that AI doesn't replace creativity, but amplifies human potential by offering new ways to express ideas, breaking down technical barriers that previously limited artistic exploration. In music composition, AI tools like Amper Music or AIVA demonstrate this collaborative dynamic. Composers use these platforms to generate harmonies, rhythm structures, or ambient soundscapes. However, the final creative decisions, melody, arrangement, or thematic resonance, remain deeply human. For example, film composers often rely on these tools to expedite the initial brainstorming phase, freeing up time to refine and inject their personal artistic vision into the score. Here, AI serves as an assistant, expanding the boundaries within which creativity can flourish rather than substituting for the nuanced artistry associated with human musicianship. Storytelling further dismantles the notion that AI replaces creativity. While platforms like ChatGPT or Jasper AI can help draft story frameworks or dialogue snippets, they rely heavily on pre-trained patterns from literature, film scripts, and storytelling guides. Human writers infuse stories with cultural context, emotional arcs, and thematic depth, elements AI cannot authentically replicate. Think of AI as the scaffolding for a writer's creative process. It generates starting points, but the heart of the narrative, its ability to connect emotionally with readers, remains distinctly human. This underscores AI's true function in creative industries, not as a competitor, but as a collaborator that amplifies human creativity. As we conclude, it's essential to emphasize that while artificial intelligence is a powerful and transformative technology, it is not the all-knowing, autonomous entity depicted in science fiction. AI thrives within the boundaries of human-defined parameters, relying heavily on pre-programmed algorithms, curated data, and objectives set by its creators. Each myth we've deconstructed today highlights a recurring theme. AI's limitations are as significant as its capabilities. From its inability to truly think or feel, to its susceptibility to bias, AI is far from being a universally flawless system. Recognizing these constraints is crucial to temper expectations and foster a realistic understanding of its potential. One of AI's greatest strengths is its ability to handle repetitive tasks, analyze vast amounts of data, and identify patterns that might otherwise take humans much longer to notice. But it's important to keep sight of the fact that AI functions as a complementary tool, not a replacement for human creativity, empathy, or critical thinking. For instance, tools like ChatGPT or image generation software may create outputs that seem magical, but they're grounded in probabilities, pattern recognition, and trends derived from historical data. These systems don't innovate or possess intentions. They assist humans in achieving their objectives more efficiently. Approaching AI as a partner rather than a substitute is key to making the most of its strengths while countering unrealistic fears. Ultimately, the myths surrounding artificial intelligence often stem from misinformation or the projection of humanity's fears and hopes onto technology. By critically evaluating AI's true capabilities and limitations, we can strip away the myths and understand it for what it is, an evolving discipline that will shape our world with both promise and responsibility. As we move forward, the challenge lies in engaging with AI as informed individuals, asking tough questions, advocating for transparency and ethical safeguards, and staying aware of how it affects our society in measurable ways. Armed with knowledge, you can not only embrace the opportunities AI offers, but also play an active role in ensuring it's a force for good. If you want more no-fluff videos like this on deconstructing AI myths, subscribe now and share this with one friend who follows the game.